Can you guys see my screen?
Yes. Yes.
Okay. Um. My laptop is disappointing me. I don't know if it's network issues or what, but yeah, any part. So when we look at okay, tree. Okay, so we're gonna start with the basics, which is gonna be the trigonometric ratios. So I'll just summarize it as trig ratios. So trig ratios are gonna help us understand the relationship between the sides and the angles on the triangle. And then we have sine theta, where theta is the angle. And then also have cos theta, and then also have tan theta. So when looking at this, I want you to memorize this. It's a mnemonic. So car tour. Okay, so car tour. This is gonna be very helpful. Like you have to understand this, memorize it. It's gonna be very helpful when solving problems for trigonometry. So what this soccer tour stands for is under saw. It means sine is equal to opposite over hypotenuse. And then for car is going to be cos. And then the A here stands for adjacent. And then the H over hypotenuse. Same with the tour. So it's going to be the T for tan is equal to the O for opposite over adjacent. Okay, so once you have this in mind, now we're gonna go into the triangle and then I'll show you how to actually apply these. So looking at the triangle, the right angled triangle, let's say this was our theta. And then we always know that the hypotenuse is the longest side of the triangle, which is going to be this side. This is our hypotenuse. So let's say here the length of the side was a 7 and the length of this side was a 3, and then you're asked to find the value of sine theta. So sine theta, okay, let's write our mnemonic again. So car tour. So if we're to find the value of theta, I mean of sine theta, so we're gonna say sine theta is equal to, and then we look at the opposite side, like where the angle is facing. So the angle is facing that. I'm so sorry. Okay, as I was saying, the angle face points towards the opposite side, which means if we also had an angle here, let's say it was 60, the opposite was gonna be this side. Is that clear?
Yes.
Okay, so with being that, okay, so we now know what the opposite side is, but then I'll also explain what the adjacent side is. So where the side that the angle is on top of, that's the adjacent side. So here, when we look at theta, it's on top of the side with the 3. So that's the adjacent. When we look at 60 degrees, it's on top of the side with a 7. That's gonna be the adjacent for 60 degrees. So let's get into this. If you're asked to find the value of sine theta, you're gonna say sine theta is made of the opposite over the hypotenuse. Our opposite side has a 7, so it's gonna be 7 over and then the hypotenuse. For now we don't have a value there, but let me just put an 8. For now we're not calculating the actual values. I'm just giving an example, trying to explain what this is. Okay, so it's gonna be 7 over 8. And then if we're to ask to find sine 60, then it was gonna be 3 over 8. And then if we're asked to find cos theta, can you tell me what cos theta would be? Please try,
Cos
even
theta,
if
cos
it's
theta,
wrong, it's
right?
okay. Okay, so I say look at this. So, hello.
It's gonna be 3/8.
Okay, yeah, that's correct. And then how about tan 60?
3/7.
Good. Yeah, that's correct. Um, okay, so I'm thinking you've understood this. So for the next one, we're gonna look at the trigonometric ratios in the Cartesian plane. But this one, I would like for us to start with the Pythagorean theorem, right?
Yes.
Okay, that's good. It means you can skip it. So um, we have our y-axis and then also our x-axis. So okay, so here is our triangle on the first quadrant, and then we also have our angle. The value of our angle is theta. So when you look at the y value, okay, let's say we have a point right here at the top. I'm not sure if you're able to see that. Here. Yeah, let's say that's our point. Our point is gonna be having an x and a y value, right? So the y value is gonna represent this side, and then the x value is gonna represent this side. So our y value is gonna be equal to sine theta. Do you agree?
Sorry, can you please repeat?
Okay, so I'm saying okay, let me start before drawing the triangle. Okay, let me say on our Cartesian plane, if we're to have a point here, this point would have an x value and the y value, right? Do you agree with that?
Yes.
Okay, so and then when we go back to the first diagram on the left, so what I'm saying is when we have this point here and then we've drawn a triangle, the vertical side, which is this vertical side, is the length of our y, and then let me change the color. And then this side is gonna show us the x value. So what I'm saying is the y value is equal to sine theta. Why is it sine theta? Well, it's because the angle theta is facing this side. So to find the value of this side, we're gonna say sine theta, and then did you understand that?
No.
Okay, I'm not sure of how else to put it, but it's okay. Okay, based on what we have learned before, if I asked you to find the value of y, how are you gonna calculate it? Let me scroll back for you to look.
I was
Okay.
going to say,
Uh-huh.
but how are we going to calculate it without the value of theta? Because actually there must be one unknown for you to get the answer.
Okay, let's say theta was 30.
Okay. So our opposite is going to be y, and then our hypotenuse is going to be 8.
Mm-hmm.
Mm.
Yes, you're in
And
the
then
right direction.
and then for sine theta, there's an invisible one, which is sine 30 all over 1, and then we're gonna cross multiply.
You're saying sine 30, like this.
And then is equals to y over 8. And then cross multiply.
So this is what you mean, right?
Yes.
Okay. Alright, that's actually correct. Okay. We'll come back to this now. I feel like if I explain the other stuff first and then come back to this, it will make more sense that way.
Okay.
Yes. And before we continue, before I waste your time, have you done these things before?
Yes.
And you understood them?
Yes.
Okay, can you please tell me how far you are? I think now I can hear you properly.
Okay. So um where's this? So actually the problem is in the grade 11s. I mean the grade 12 stuff like compound angles, identities. Yeah, that's actually grade 11. Like uh calculation for getting an identity, compound angles, double angles, and also general solutions like the grade 12 stuff.
Okay. I hear you. Okay, so the first thing on the list is compound angles, right?
Yes.
Okay, so with compound angles, okay, let me just first write how they look like, and then it can be like theta plus minus beta, and then of course, and then theta plus minus beta. So this is what they look like. So in order to be able to solve compound angles, you first need to understand I forgot what they're called, general angles, something like that. For example, what cos 30 equals to, and let's say tan 45, right? And then with this the best way to find it without even using a calculator is by using these triangles. So there's two triangles, both of them are right angled triangles. So for the first one, we have root 3, and then here we have z1, then here a 2, and then where there's root 3 it aligns with 30 degrees, and then the other side is 60 degrees, and then we have this one of 1 and 1, and then it's root 2, and then it has 45 degrees on for both angles. So if you know this, then you'll be able to, it should be easy for you to solve the compound angles. Okay, and then with compound angles, for sine, when we're dealing with sine, if it's sine theta minus beta, okay, let's start with the plus beta, it's gonna give us if I continue. Is this the correct thing that you're looking for? I didn't get to this. I thought maybe we're Can you still hear me?
Yes.
Oh, I was asking, this is what you're asking for, right?
Uh-huh.
Okay. So I think a you guys have a formula sheet, right?
Yes.
Okay, so I'm not sure if it's gonna have this formula or not, but then yeah, when it's so with the compound for sine, I want you to notice that when we have a positive here at the center, also here there's gonna be a positive. That's what you must notice. And then also gonna start with the sine theta, which aligns with the first angle this side. And then the following angle is beta, so it's gonna be cos beta. And then when you after the plus sign, you switch it up, it's now gonna be cos theta, and then uh, sine beta. And then when there's a negative with sine, it's still going to be sine theta and then cos beta minus, please take note of the signs, minus, and then it's going to be cos theta sine beta. The reason why I was emphasizing on the signs is because when we're now working with cos, it changes. So for cos, if it was cos theta plus beta, it's now gonna switch. And you also have to notice that for cos, when it's cos, we start with cos before the sign, like it's gonna be cos times cos and then minus and then sine times sine. So for cos, it's gonna be cos, you start with the first angle, which is gonna be theta, and then cos beta. Here it's a positive, it's gonna change and be minus, and then sine theta sine beta. So I'm gonna circle this so that you so for now, can you please tell me what it will give if it was cos theta minus beta?
Um.
Remember, for cos the sign changes. Yes.
Okay. So it's gonna be cos beta plus sine theta and sine beta.
Okay. That's actually correct. Okay, and then going into the actual like okay, so normally when they give you, they won't give you to you like with the two angles. They'll just give you something like, okay, so let me start with the sine. Sine 75, right? And then like you're supposed to solve this without a calculator. So how you're gonna do this is look for two angles that you can get from the triangles that add or subtract. So when we go back to the triangles, we have a 30, there's a 60, and then there's like 45. And then other special angles are gonna be like 90, 180. Yeah, but for now, let's focus on these ones. Okay, so 75 is made up of 30 plus 45. Like the order doesn't matter. You can write it as 30 plus 45 or as 45 plus 30. So this is going to become sine 30 plus 45. Do you now see that it's in the form sine theta plus beta? Do you now see that?
Yes.
Yeah, so we're gonna go ahead and use that expression for when it's sine theta plus beta. So it's gonna be sine 30 cos 45, and because it's a sine and a plus here at the center, it's plus, and then cos 30 sine 45. But then we're not allowed to use our calculators because the instruction will normally be without using your calculator. So then we draw our triangles. 1 over 3, 30 degrees, 60, 1, and then 2. And then we also have this other one. This other one, and then it has 1, 1, 45, 45, then a root 2. Okay, so here we're gonna look at the first one, sine 30. So the value of sine 30, we come here to our triangle. Sine 30 is made up of 1 over 2. So sine 30 is 1 over 2, and that's what we're gonna write. And then we now look for cos 45. And then cos 45 is gonna be, okay, here with the 45 degrees, you can use like any angle because they're both 45 and they're still gonna give you the same answer. So it's gonna be like, sorry about that, I actually did the, okay, so it's 45 with the adjacent and then over the hypotenuse, so it's gonna be 1 over root 2, and then plus, and then we look for cos 30. Cos 30 is gonna be this. So it's gonna be root 3 over 2, and then we're gonna multiply it with sine 45. If you do it, you'll notice that sine 45 is actually 1 over root 2. So you're gonna multiply these out. So it's gonna be then 1 over, and then multiply the denominators, 2 root 2 plus root 3 over 2 root 2. And then, okay, since we have the same denominator, it's easy to add 1 plus root 3 over okay. No, thank you. And then I tried to reduce the price and just keep on going down, and I had to pick and choose. And that will be our answer. Did you understand?
Yes, I did.
Okay, and then just to confirm, we can press it on our calculators. You can type sine 75, and then oh, it's okay. I'll just type it for us, just to also make sure that I didn't make a mistake. 5, 9, and then this one plus 3 over 2, 3. Oh shit. Um, I know I got that. Like, damn. Turns out it's not the same. So I must have done something wrong somewhere. Yeah, I had like in my car, but I had to choose one. Yeah. I love this bag. And sweet. Wait, did I buy that? Did you perhaps notice anywhere where I made a mistake? Oh, yeah. You never know. Sibo, you can also help us. Fans. Like, oh, nah, I bought something like that. Oh, did you see my? Oh yeah, you saw the bills. Yeah, this is my first basket. I had to split it into two. People are busy taking me pictures. You know. Yeah, this is my second one. I almost. Now, when I
Not
see it,
around.
I wish I was around.
Maybe he's not around.
Oh, his okay, okay, it's fine. I'm trying to see where I made the mistake, but this is the method. That's how it goes. What? 12 inches is such a
Okay.
yes. You mean the bulb? I like bulbs. No, but like I'm saying, 12 inches is an upper limit. There's 10 inches. Okay. Let's just do another question. We'll see what we do. Then yeah, I'm hoping we won't make a mistake again.
Okay.
Please, when I'm going through, if I make a mistake, please raise it so that we avoid making silly mistakes. Yeah. And then let's now work with cos. I'll use the same value, cos 75. So how would you express it as, like, what would you write if you're to be given cos 75 and then you're asked to solve it without using a calculator? Yeah, I just wanted the shells. Maybe I could
Firstly,
customize for
I'll
you.
expand it, which is gonna be cos 30 plus 45.
Yeah, from this. Oh, you see now another one is coming on. Okay, yeah, that's actually correct. And then what would your next step be?
And then I'll equate it to cos 30 cos 45 minus sine 30 and then sine 45.
I also wanted this other one. Okay, cos 30 cos 45 minus sine 30 and then sine 45. Okay, that's actually correct. And then what would your next step be? The reason why I ask is so that I make sure it's not passive, like it's not only me talking and then you keep on saying yes, you understand. Like I just wanna make sure you actually do understand. Okay. So please
Okay.
help me. Yeah. Wait. Maybe I should draw the triangles. Three and then 30, 61. Two, and then also have this triangle and one, 5, 5, 2. Okay, yeah, so what would your next step be?
And then I'll go to the triangle where there's angle 30 first.
Okay,
And since cos is for adjacent all over hypotenuse,
yes,
my adjacent side will be root 3 all over 2.
okay, that's correct. And then next,
And then I'll go to a triangle where there's 45.
mm-hmm.
And then I'll also look for a adjacent and hypotenuse.
Okay, so that's gonna be 1 over root 2, and then minus, and then sine 30, and then sine 45. Okay, so I'll just do this one for us. It's going to be 1 over 2 multiplied by made a mistake here. It's actually root 2 over root 2. And then okay, so that's going to be equal to root 3 minus 1 over 2 root 2. Okay, so for this one we didn't make any mistakes. You can punch it in a calculator to confirm. So when I punch it in the calculator, just to confirm that our answer is actually correct and we didn't make any mistakes along the way. It's very important to always check, just in case. So 2 2. So this is giving me 0.2588, and then let me see, cos 75. Yep, it's giving me the same value. So which means we've done our calculations correctly. So do you now understand how to work with compound angles before we go to a complex one?
Yes, but can you please explain when they say uh, prove this equation?
Um okay, can you give me an example? You can also send it on the WhatsApp group.
No, like sometimes they usually say prove sine theta plus beta is equals to sine theta cos beta plus cos theta sine beta.
Sine theta, then Then what?
For this can I use the same ones as they usually put that plus. Sine theta plus beta.
Or like they're like this, and then you have to prove that it is equal to sine theta cos like this.
Yes.
Oh, okay.
I'm using my body out to back. At least my voice is coming back. Yeah. I mean, I need to change. I don't know what I'm going to change it to. The outcome you need to all has is basically the outcome you need to the valve. Yeah.
What do you mean?
Oh, we're proving this identity.
Okay. Yeah, I think we use the double angle of side. Like you see the left side is sine. Wait. Oh yeah. It is 2 sine theta cos beta. Yes, I forgot to start. Were the angles different even on the question, or you made it up?
Sorry, I can't hear what you're saying.
Were the angles, were the angles different on the question, or you make the question up?
It's from an exam question.
Or like the angles were theta and beta, or
Yes.
okay. Yeah, let's change the right side to 2 sine theta cos beta.
Do you have your material with you?
Today with me. Oh no. First, let me do it on paper first, then I will respond back.
I don't know. For some reason, I don't ever remember proving this, but okay.
Let's ask the real question on the chat.
She's just giving an example of how it will like look like.
Oh, she doesn't have the question.
Sorry.
Like, can you please give us the exact question, like it might not necessarily be like this.
Yeah,
Okay.
because this is an identity. How I know they normally ask questions would be something like maybe they're like cos and then alpha plus beta, and then they're like show or prove that it is equal to, and then they write something like cos 2 alpha, or maybe they write 1 minus 2 sine squared alpha, right, like this, and then you have to apply this identity here, and then as you simplify the equation you end up with this solution. That's how I know it. But proving this itself, this is something they're
Uh,
supposed to do.
I've seen questions like this in it, but not with different angles. Like there was always something on the angle. It's either the angles were the same or the question wasn't like this exact.
Okay, let me check for it.
Yes.
Yeah, yeah. Are you finding it?
I got the different one, but I once did a question like that.
With different angles?
It was just written like uh sine theta plus, and then sine theta plus beta, and then you had to prove that.
Different angle.
Sorry?
Oh, you need to prove the compound angle.
Yes.
Sure. Like,
I'll send it when I get it.
oh, okay, okay. Yeah, for now, let's move forward.
Should I send the one that I got?
Yeah,
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 click.
you can. Oh, yeah. Mm. I think on this one. Wait. But let me do it quick. I will respond when I'm done.
Okay. So are you gonna completely do it or should I also attempt it?
Oh, yeah, you can attempt it.
Okay.
No, but I was gonna use the reduction. Are you gonna use reduction?
Yes.
Yeah, I was gonna use reduction. So, like, if you can do it using reduction, then it's unnecessary for me.
You can still go ahead and do it.
Okay. Oh no. I think she sent the solution on the group. Like you can check.
Did they also use this? Because I wanted us to start from. I think this is already given. You just have to know, and then use it to
Yeah.
manipulate. Yeah. Because whenever at the top you're given something with a sign, and then also an
Mm.
angle of some sort, and the end solution has a cos.
Oh yeah.
Yeah. Yeah, there's higher chances that you have to use the sine 90 minus theta to convert it to cos theta.
Yeah.
Yeah. But then, okay, let me look at the solution so that we see.
Yeah, they use the reduction on the group as well. My own the solution as well.
Oh, they also did that. Okay, so here after looking at the solution, you're not understanding what was happening here. Oh,
Yes, some.
Can you just like explain it?
Yeah, like, what that is proof like it's kind of upsetting. But they are using the combined angles. I think on this proof they are just showing us how the signs. Yeah, they are proving the signs, not the compound angles exact. Especially on the first one.
can you explain more? I'm lost.
Mhm. Like, look at that first solution. They
Yeah.
didn't prove what they are not proving what cos theta plus alpha is equal to cos theta times cos alpha plus sin theta plus sin alpha. Like they are basically showing us that cos if you substitute positive with negative, like you get negative on one, you get positive on the one of cos or like something like that. They are not proving the compound angle exact.
Oh,
Yeah,
like they're
yeah.
showing
They are
us how the sign changes on the first one.
Yeah, yeah, yeah.
Yeah. Pindi, you're saying something.
I read that question. They said you must prove it.
Huh?
Which one?
The question that I said I was going to look for. Don't see it now. I can't find it.
What the first question?
No, like they said you must prove that equation. So I'm not getting it when they say they're just proving the sums.
Wait. Use the following identity to deduce that. Oh, these are two different questions.
Yes.
I said this because I can find that question. It's okay.
Oh, okay. Yeah, but on this one, I think we are basically rotating alpha by 90 degrees or beta by 90, or let's say alpha by 90 degrees, then yeah. Nutrition, like, are you getting it? Like if we rotate alpha by 90 degrees, we are getting the second identity.
Which is this one that I wrote on the other side, right?
Yeah, the cos alpha, cos beta plus sin alpha, sin beta.
Okay. This is not the angles.
Oh, wait. Uh, let me share. Oh, okay.
I'm not sure if I'm gonna be able to explain this, but then yeah, you help me where I fail. So if you look at this, you're given like this. This is what you're given, and then they further expanded it as the sine, cos, and then cosine. And then the final solution, if you look at it carefully, the final solution, the cos alpha sine theta minus sine alpha cos theta, it can simply be expressed as this. Are you able to see that?
Yes.
Okay. So if you're able to see that, so what they're basically asking us to do here is to move from this to this. But then we also given this identity. If you wanna switch, okay. If you wanna switch from a sine to a cos, you're gonna have to involve a 90 minus the angle that's inside. So, how can I do this? So for now, let's say this angle, need a different color. This angle we'll express it as beta minus alpha. So if we express it in these terms, it means it's gonna be sine x. Do you understand what I did here?
Yes.
Yeah. Okay, so if it's like this and then we wanna change this sine x into cos x, so we're gonna say sine 90 minus x. Okay, and then it's gonna give us cos x. But then what's our x value? Our x value is this theta minus alpha, so I'll just suggest we substitute it here now. So it's going to be 90 minus theta minus alpha. Can I just do it without referring? Because now okay, I'll just do it without referring. And then we're gonna get sine. Okay, it's gonna be 90, but then we have this minus on the outside. So the minus is gonna make the theta negative, so it's gonna be negative theta. But then minus minus makes a positive, which is gonna be plus alpha. Is that okay?
Yes.
Okay. I just realized something. I actually did the opposite. Sure.
Yeah, I think even if like you can just maybe let theta minus alpha is equal to x, then you do the 90 minus x, then you change it to cos x, like reduction. Then after that you return theta minus x instead of x, then you just do the compound angle normal. Like I think it will still work.
Yeah, I know that, but then I think what she wants to understand is exactly what they wrote down here.
Oh,
So I should have worked with the cos one because after all they're equal.
yeah, yeah, they are equal.
So it means instead of sine 90 minus x is equal to cos x, we're supposed to use cos 90 minus x, which is equal to sine x.
Oh, Kala, Sami, do you understand?
No,
Yeah?
no, I'm not getting it.
Yo, we are cut.
She's saying she doesn't understand.
Oh, it's like, do you have a calculator on your hand?
Yes,
Oh, press sine theta. Yeah, yeah. Compute sine theta.
sentence.
Yeah, yeah.
Okay. And then
Yeah, what answer do you get?
1/2.
Okay, then clear everything. Now compute cos 60.
I'm getting 1/2.
Yeah, yeah. So reduction is basically the to oh, then do 90 minus 30.
Sorry, can you please repeat that?
Oh, I was saying do 90 minus 80, like just a difference. 90 minus 30.
For which ratio?
Can you do for sine?
Okay.
Oh, yeah. Yeah, Lutricia, please write. Oh, okay. Wait. Oh, I was trying to show you that the reduction is basically saying this thing of sine theta is equal to cos theta, my cos 60. But now we are using the the unknowns, not the real angles. Usakhona?
Yes.
Usuyayibona le i-reduction ukuthi like ithini, like basically.
Yeah.
Yeah. Manje asibuyeleni-ke la kule proof yangempela manje. Usacela ubuyela phezulu nje Tricia. Usacela uscroll up, I mean. Yeah. So basically on that first step, wait, what did it do? Oh, let me see. Oh, Lutricia, can you go please do, what did you do? Let me see. Awuthi ngiqale ngiyibhale phasi kuqala khona ngizoyibona.
Okay.
Oh, okay, sengiqedile. Awuthi ngishare iscreen nje Lutricia manje sis. Khona ngizo. Yeah.